Okay, this is the lecture video for MAT 1100. We are in lesson 4.7 where we're going to take a look at the parabolic shape. Okay, here you see graphed a curve that is referred to as a parabola. This happens to be an upward parabola, and that's because both of the legs on this parabola open upward. Okay. Then I also would like you to be able to locate the intercepts. Now we have talked about intercepts, but mostly with reference to a line. An intercept is just where the curve, this is called the curve, it just happens to be a curve that is specifically referred to as a parabola, but it still has intercepts. Intercepts again are just where the curve cuts through either the x-axis or the y-axis, depending on which intercept you're looking for. So when you're looking for the x-intercept, you want to know where the curve intersects. Where does the curve intersect the x-axis? And when we ask you for the y-intercept or intercepts, because sometimes there are more than one, sometimes there's more than one x-intercept, sometimes there's more than one y-intercept. So when I ask for the y-intercepts, I want to know where does the curve intersect the y-axis. Okay, just reminding you what x-intercept and y-intercept means. X-intercept is all about the curve crossing the x-axis, and the y-intercept is all about the curve intersecting the y-axis. So in this particular problem, the x-intercept is right here at 2. And you can name that x-intercept like this, or you can name it as an actual point, where you give an x and a y coordinate at this position. So if you were naming that as a point, it would be called 2 over for your x coordinate, and that point is 0 units up in the air. It's right on the x-axis. Be prepared to answer that either way. Especially on the final exam, you know you're going to be have to select from the choices that are offered to you, and it can sometimes be offered like this or this, so be prepared to answer either way. With respect to the y-intercept for this particular curve, where does this curve cross, that's what intersect means, cross the y-axis? Right here. Okay, so this would be referred to as the x-intercept, this would be referred to as the y-intercept. I guess I can label that here. Okay, now you can say that this is 1, or you can be even more specific. You're being more specific when you give it as a point. Okay, that location right there would be called, with respect to an x and a y, 0, because you're not, this point is not to the right, nor is it to the left. It's directly located on the y-axis, 1 unit up in the air. So it would be referred to as 0, 1. Okay, and this was our x-intercept. Okay, this point that you are seeing right at the x-intercept also happens to be called the vertex. Sometimes the vertex may coincide with the x-intercept, and sometimes it doesn't. It depends what kind of parabola you have. And I'll show you other examples of parabolas where the vertex is not the x-intercept. So I don't want you to think that the vertex is always the x-intercept, because in fact sometimes it is not. Okay, but at this particular, for this particular graph it is. Now, because it can sometimes be in other locations, I want to describe to you what a vertex is. Notice that on this graph, the graph is excuse me, is decreasing. It's going down, down, down. As you travel along the curve, the y values are going down, down, down. So it is, this side of the graph is said to be decreasing all the way until you get to this point. Then all of a sudden, instead of falling down the side of the graph, now you're rising. And we did study in previous sections the difference between decreasing and increasing. So if you are scanning this graph left to right, taking a look at it, or in other words, traveling, starting on this side on the left and moving to the right, all of a sudden you're going down, which is considered decreasing. And right at the vertex, you change from decreasing to increasing. Decreasing and increasing is all about what the y values are doing. So on one side you're falling, and on the other side you are rising. The point at which that change occurs is known as the vertex. Now, every point, the vertex is a point. Every point has an x and a y coordinate. We've already discussed that not only was this the vertex, but it was also the x-intercept. And we discussed what the coordinates were right at that x-intercept, but now we know it's also called the vertex. And yes, we could call it x and y, and in fact we do refer to it like that. But if that xy pair happens to be the vertex, we have a special name at the vertex for x and y. Instead of calling it x, we call it h. Now this is only at the vertex. And the y coordinate we actually call k. Any time that you're talking about any other point on this graph, like if I was going to talk about anything other than the vertex, I would refer to it as x and y. But when you're at the vertex, we refer to the x coordinate as h and the y coordinate as k. And that is good to know because when you're asked this question right here, what is the axis of symmetry? You're going to see that that is related to the vertex. You need to know the vertex first before you can answer what is the equation of the axis of symmetry. You need to know the vertex first, and that's why I discussed it before giving this answer. So since we've already discussed it, now these are too small, so I'm just going to write it down here. Okay, since we've discussed the vertex, I'm going to go ahead and write that answer where they're asking for the vertex. Yes, I could refer to this as x and y, but we give the x the special name of h and the y coordinate the special name of k, only when you're at the vertex. Well, regarding the equation for the axis of symmetry, and I'll give you a picture on what an axis of symmetry is. It is a line that comes right through the vertex, a vertical line that comes right through the vertex and splits the parabola into two symmetrical halves. And by symmetrical, what I mean is if you were to crease your paper right here on the axis of symmetry, if you were to fold your paper, you would have a matching image, or what we call a mirror image, lying right on top of the other side. These two halves would match. So the axis of symmetry is actually what causes that, right at that line. And I'll label this right here, axis of symmetry. Right at that line, you could crease the paper and superimpose one half right on top of the other by folding the paper right at that line. We also can name this line using an equation. And that is what I'm going to give you the formula for right now. The equation for the axis of symmetry is x equal to the h value. You're going to use that formula to give the equation for the axis of symmetry, this vertical line right here. Okay, what was the h value? Right here. It's actually the x coordinate at the vertex. So when asked to give the actual equation for the axis of symmetry, you will give x is equal to and whatever that h value is. This is just the formula for the equation of the axis of symmetry. Okay, so just some basics about a parabola. How to identify the intercepts, how to identify the vertex, how to use the vertex in order to identify the equation that stands for the axis of symmetry, which is just a vertical line that splits the parabola into two symmetrical halves. Okay, let's try this again. Now, instead of doing an upward parabola, on the next page we'll look at a downward parabola, and that's because the legs point downward. The opening is downward. In the other picture that we just saw on the previous page, the opening was upward. So does the parabola open upward or downward? Excuse the dogs, they may bark a little. It is opening downward. Okay, part B. Find the equation for the axis of symmetry. That is not until you find the vertex. So you have to find the vertex first. Okay, again, notice there is a point at which this graph switches from increasing to decreasing or vice versa. Remember, you're always supposed to look at a graph going left to right. You can travel this curve, but start on the leftmost side and move this way. So, if I'm traveling up this side of the graph all the way to the tip top, or what we refer to as the vertex, I am increasing, increasing, increasing. I'm rising. And all of a sudden, the increasing nature of this graph changes right here at the vertex. And now instead of increasing, if I'm to continue traveling on this curve, all of a sudden I'm falling, falling, falling. And that's called decreasing. So the point at which the graph switches from increasing to decreasing, that is known as the vertex. Notice that unlike the last graph that we just looked at, the last parabola, this vertex is not the x-intercept. Because some students will ask me, is the x-intercept always the vertex just because that's the first example that they saw? When in actuality, the vertex can be in many different places. It can be somewhere where it's not on an axis at all. It can be above the x-axis. It can be below the x-axis. And in either one of those situations, when your vertex is above the x-axis, then that vertex can't possibly be the same as the x-intercept, because an x-intercept is right on the x-axis. Notice that this vertex is not. Sometimes you have an upward parabola and the vertex is down here. Again, not on the x-axis. So the x-intercept is not necessarily the vertex. The way you can always tell what the vertex is that it will be the point that separates the increasing portion from the decreasing portion. Okay, the coordinates for this particular vertex is it's over 1 unit and it is 9 units up in the air. Remember that although any point on the side of the parabola is referred to as x and y, at the vertex that x and y get a special name, h and k. But if I was to identify any other point on the graph, such as a point on this leg right here, I could say, hey, what's that point? That point would be 3, and then it's 4 units up in the air. Points like that are on the sides or the legs, as we call them, of the parabola, those are referred to as just simply x and y. The only point that has a different name, and instead of being called the x and the y coordinate, is referred to as h and k, would be the vertex. And that vertex is what helps you get the equation for the axis of symmetry. So you always need that vertex first if you hope to get the equation for the axis of symmetry. Remember the formula for the line which represents the axis of symmetry. It always goes right through the vertex. Okay, this line right here represents the axis of symmetry. That axis of symmetry will always travel right through the vertex. The axis of symmetry always goes by this equation. X is equal to whatever the h value is. That's where we get the equation that represents this vertical line. So what was our h value? Just the very first number, the x coordinate at the vertex. We refer to it as h. So when they say what is the axis, the equation for the axis of symmetry, x equal to 1. I put it in the graph as well as here. Intercepts. Intercepts just means where does this parabolic curve, where does the curve touch the x-axis? Okay, that's known as an x-intercept. Now, maybe there's one and maybe there's two. This particular parabola has two x-intercepts. It cuts in right at -2, and it also cuts in at right at 4. Okay, right there. Now you can also give these answers like this. -2, 0, that is one name for this point right here. Oops. It's -2 units this way, 0 units up in the air, that particular point. And this point right here could be called 4, 0. Okay, what would make this wrong if you give me this answer on a test, and this has been done quite often, so I have to mention it, is if you take these two singular answers and put them together like this and tell me that that's what the x-intercept is. That would be wrong, because that's like saying that this parabola touches the x-axis. Imagine if I was asking this question and you gave me the answer like that. Again, it's a commonly answer that is given that has to be marked wrong. That's like saying that this cuts through the x-axis right at -2, 4, and of course this parabola does not touch at -2, 4. It doesn't even pass through those points. -2, 4 would be, let's see, that's like saying the x-intercepts at -2, 4. So -2, 4 would be -2, and then it would be up here somewhere. And it does not pass through that point, nor is that point the x-intercept. So don't collect these together and give a brand new point. This -2 is the same thing as this, and this 4 is the same thing as this, if you're going to report it using an x and a y coordinate. Y-intercept, you want to know where does the graph cut through or cross the y-axis. There's lots of different ways to say it. Just giving you a different way to say intercept. Okay, so this particular graph cuts right through the y-axis right there. The graph comes and touches the y-axis right at 8. Okay, so you could actually say the answer like this, or you can say it as a point with an x and a y coordinate. This point that is 8 units up in the air is called 0, 8. The x coordinate is 0, the y coordinate is 8. And we had already talked about the vertex. I'm going to write that a little bigger. Those spaces are just too small. So 1, 9. Okay, so we had an upward parabola and a downward parabola. And in both of those problems, we discussed whether it opened up or down. We discussed how to identify the vertex by seeing where the graph switches from increasing to decreasing, where it switches from rising to falling. That would be the vertex. First coordinate of the vertex is the value that we use to write the equation for the axis of symmetry. Any line that is vertical like this is called x is equal to, and then the front value is what's used, the h value in that equation. So we learned how to do that, and then we also talked about how to identify x-intercepts and y-intercepts for both of those problems. We finished this section on second-degree functions, where we are looking at the parabola, which is the shape of a second-degree function. And now we have some functions that are first degree and third degree, and all we're doing for those functions is learning how to evaluate them. In other words, we're going to be asked to substitute a particular value into the function. So when they are giving you the command in this form, that's just like saying plug in -1 for x. Okay, that's what you're being commanded to do there. So if you're using this particular, they're telling you the name of the function. It's called the f function, and this is what you're plugging in for x. Okay, so go grab this function, announce what you're plugging in on the left-hand side, but then actually carry out the work on the opposite side. If you are going to put this in your calculator rather than doing it by hand, press it in exactly as you see it, wrapping parentheses around this negative before raising it to a power. So this would be 3. Bring this down a little bit. So 3 times -1, close that parenthesis, raise it up to the third power, then add 5. Exactly like it looks right there. And the answer is 2. Okay, for this function right here, they have asked you to take the g function. That's why they're talking about the g function here, and I'll put this answer here as well. And they're asking you to use -3 for x. That's what that command says. You're going to use this value plugged in for x in the g function. So here we are plugging in the -3, and then on this is just an announcement of what we're going to do, and then over here we actually carry out the work. Okay, so this -3 is the input. The answer that we get is the output. Same thing here. Number you plug in, -1 is the input, and the answer is the output. Okay, so again, you can put it in your calculator if you'd like, if you feel like you need to. This is 5 times -3 minus 1. So 5 times -3 minus 1. And that's -16. These answers that you're getting, they can even be plotted as points on an XY grid. If you were going to plot a point that represents what you got here, you used -1 for x. That is what we plugged in for x. And the answer that you get is considered the y value. If somebody asks you to plot, if you are asked to plot the answer. Okay, this right here, we plugged in -3 for x, which resulted in an answer of -16. The answer represents the y value. Okay, so in this section, 4.7, we looked at parabolas as well as how to evaluate functions of various degrees. And these are the two examples. That concludes section 4.7.